Hey guys, so welcome back to another video. Today we're just going to quickly go over a review of the G3 transformations outcome and talk about the pixel art project for this unit. So first of all, we're going to start off with a review of translations, which involves moving your image horizontally or vertically, left, right, up, or down. So for example here, if I were to horizontally translate this 4 units to the right, and I were to also at the same time move it 2 units down, what I would have to apply those translations on is to each one of the vertices that I've pre-labeled over here. So to start off with, we're going to have -2, 3. We're going to move this point 1, 2, 3, 4 units to the right, and then 1, 2 units down. So our next point would be right here, and I will label this as 2, 1. I'm going to do the same thing with this vertex here, 1, 2, 3, 4 units to the right, and then 1, 2 units down. So B would be 4, -2. And last but not least, I would do the same thing with this vertex here, 1, 2, 3, 4 units to the right, and then 1, 2 units down. So C happens to be 0, 0. And I can go ahead and connect each of those points with a straight line. And that's how we'd do a translation horizontally or vertically. Next, we're going to start to look at dilations, which means really just to enlarge or to shrink your image or object by a certain scale factor. All right, so we're going to either enlarge or shrink something with a scale factor. So let me clean that up a little bit. So enlarge or shrink with a scale factor. So normally, if your scale factor is greater than 1, then you're going to enlarge. If your scale factor is less than 1, then it's going to shrink. So for this particular example, we're going to work with a scale factor of 2. Okay, so if our scale factor is 2 in this case, all that means is I'm going to take each of my x and y values for each coordinate pair, and I'm just going to multiply them by 2. So starting off with 0, 0 here, nothing's going to change because 0 times 2 is 0 and 0 times 2 is 0. So our dilated B coordinate is still at 0, 0, so nothing has changed there. If we look at -2 and 3, if we multiply this by 2 and that by 2, we're going to end up with a new ordered pair of -4 and +6. So -4, +6 is located right over here. So we'd have A is -4 and +6. Let me clean that up a little bit. -4 and +6. And our last point, -4 and 2, that would mean that we need to come out a little bit. We just run out of room a little. So that'd be -8 and +4. So -8, +4 would probably be somewhere about here if we could extend our graph just a little bit. We can go ahead and connect all of those points with a straight line. And essentially what we see here is that each of our lines is twice as long as the original point. So this line right here is going to be twice as long as that line. this line is twice as long as this line, and this line is twice as long as this original line. If we wanted to shrink it, then we would just divide each of those values by whatever scale factor. So let's say, for example, if we wanted to have a scale factor of 1/2, it means that each of these points is going to be half as large. So we could either multiply by 1/2 or just divide everything by 2. Next up, if we look at reflections, they're one of the simpler transformations to work with. So we're going to go ahead and look at the 2 different types of reflections that we've covered in this topic. First of all, we're going to look at reflections over a vertical line. So in this case, our vertical line happens to be our y-axis. And the quickest way to essentially work with reflections is we can count how many units away from that vertical reflection line we're away from it. And then at that point, we're just going to make sure we're the same number of units away on the other side of that reflection line. So just as an example, if we take a look at this first point, -2, 3, we are 2 units away from this reflection line, which means that all we need to do is make sure that we're also 2 units away on the other side. And that would be the first reflection there. So A would be at +2, +3. B would just stay the same because we're at 0 units away. So we're just going to be 0 units away from that vertical reflection line. If we look at -4, 2, we are 4 units away from the reflection line. So we're just going to go 4 units away on the other side as well. And then we're going to connect each of those with a nice straight line. So hopefully something that that we were able to notice as we were doing this is for a reflection over a vertical line, all we're going to do is we're actually going to change only our x value. So notice that it goes from a -2 to a +2. Here we have a -4 and we're going to turn it into a +4. The y values stay untouched. If we look at a reflection over a horizontal line, yep, you guessed it, it's basically going to be the same thing, except now we're just going to be counting downwards across that horizontal reflection line. So here we are 4 units away, so not 4 units away, 3 units, 1, 2, 3 units away. So we're going to go 1, 2, 3 units away over here. Same thing with our point C, 1, 2 units away, so 1, 2 units away on the other side. And then I'm just going to connect those with a straight line as well. Now the only difference between the reflections over a horizontal line and the reflections over a vertical line is that instead of your x values changing, it is just your y values changing. So it goes from a +2 to a -2. And then here we go from a +3 to a -3. So only your y values change when it comes to a reflection over a horizontal line. Last but not least, we're also going to look at reflections, which I would say is probably one of the toughest transformations to wrap your head around, just because of the fact that it is a little visually difficult to kind of figure out what exactly are we doing with the shape. We understand that we are rotating it, but what does it mean to rotate something by 90 degrees, 180 degrees, or 270 degrees? Okay, so rotations means that we're just going to take whatever original shape, image, or object we have, and we're just going to turn it usually about the origin. In this case, we're only going to be sticking with the origin. Sometimes we can turn it about some random point on the plane. But before we get started, I just want to quickly review some of the quadrant numbering systems. So here on the top right, we have quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. Now the reason why we're going to bring those up is because each of these quadrants are going to have special conditions for their coordinates. So we know that an ordered pair comes in the form x, y. Now in each quadrant, number 1, 2, 3, and 4, your x or y value will always have to be either positive or negative, depending on which quadrant it's in. So in quadrant number 1, both x and y are always positive. In quadrant number 2, x is negative and y is positive. In quadrant number 3, both your x and y values are always negative. And then finally in number 4, your x value is positive and your y value is negative. So just kind of keep that in mind as we start to work through some of these rotations here. Now, as we work through the rotations, normally what your teacher would ask you to do is we'd normally have 3 different types of rotations. We can rotate 90 degrees, we can rotate 180 degrees, or we can rotate 270 degrees, and we can go either clockwise or counterclockwise. For this example here, I'm just going to go clockwise to keep it simple. So we're going to start off with our point A here. Okay, now we can imagine that we're going to take this shape and we're going to shift it over 90 degrees clockwise to the right. So we know that both of these points are going to be somewhere over here, and we can figure out that roughly if I were to pick up this triangle and plop it over here, this point would have to be a little bit further down and not as high up. And that's absolutely right. So the trick is we need to switch our x and y values with each other. So here we have -2 and 3. So this would be 3 and -2. So we're going to switch the x and y values around. But we want to refer to the fact that since we are now in quadrant number 1, both your x and y have to be positive. So instead of this being 3, -2, this would actually be 3 and +2. So that's where our vertex A would be. At 3 and +2. We would do the same thing with that -4 and 2. We'd switch it so it's 2, -4. But because we're in quadrant number 1, this would be 2 and +4, which would give us a point right up here. Okay, we've had our last vertex over at the origin, so that doesn't actually change, just to keep this this example nice and simple for us. So we're going to go and connect all of those points with a straight line. So we've gone ahead and rotated that by 90 degrees clockwise. Now, if we were to start again with quadrant number 2 and we were to rotate it 180 degrees, that would bring us into quadrant number 4, 180 degrees clockwise. Now, we're going to really more or less do almost the same thing, except when we rotate something 180 degrees, we do not change our placement of the x and y values. So this -2 and 3, they would stay where they are, except we're going to look at the plus minus here. So that means that our x value has to be positive and our y value needs to be negative. So instead of it being -2 and 3, this would now be 2 and -3. So we're going to go ahead and mark down 2 and -3 right here. So that would be A, 2, -3. Remember, those little dashes just symbolize which reflection or which transformation we've done. So this is transformation 1 and transformation number 2. I'm going to do the same thing with the C. So instead of it being -4 and 2, this is going to be 4 and -2. And then our origin stays exactly the same. And I can connect those points with a straight line. And I kind of missed the mark there. So we have straight line. Let me see if I can get us over there. There we go. It's a little bit better. All right, so that is what it would look like if we rotated it 180 degrees from quadrant number 2. Now our last rotation involves us moving from quadrant 2 270 degrees clockwise until we reach quadrant number 3. So we're going to go from here, quadrant 1, quadrant 4, and quadrant number 3. And we're going to have to once again switch our x and y values around, and then refer to the fact that both x and y both have to be negative here. So at negative 2 and 3, we are now switching, so it becomes 3, negative 2, but both numbers have to be negative, so we're going to have negative 3 and negative 2 as our final rotated point. So negative 3, negative 2. Oops, so negative 3, negative 2 would be my A. And then for your, maybe I'll get that out of the way there. And then for your C, this would end up being negative 2, negative 4. Negative 2, negative 4. We said that A would be, A would just be, having some technical difficulties here. A would just be negative 3 and negative 2. So we can go ahead and connect those with a straight line. Just like so. And that takes care of how we'd handle rotations, either 90 degrees, 180 degrees, 270 degrees, either clockwise, counterclockwise. And we're just going to make sure that we keep track of which quadrant we're in, so we understand, do our x and y values take on positive or negative values in this case. So the last thing that we're going to talk about today is our pixel art project for the G3 transformations unit. You guys can find this project in the D2L shell, either from the announcements or on the content page. So we've talked about 4 different types of transformations. So you have translations, dilations, reflections, and rotations. And we're going to apply at least one of each type of transformation to the pixel art that you create. So there's going to be 3 parts to this assignment. Part 1, you just need to make sure that you guys create your pixel art. It can be really whatever you want. The important things to note here are that you label each vertex. In your rounded shapes, it might be a little bit tricky, so just choose 3 distinct points so we have some sort of reference point for each transformation. Apply at least one of each type of transformation. Sometimes you guys might have to use multiple pages. I've provided a printout for you guys at the end of this document. The second part of this project involves using an isometric dot grid paper to make some sort of original 3D object. I'll show you guys an example and how I drew mine. And then you have to choose to either enlarge it or shrink the image. Please don't do both, just do one of them. Write a short description of what you've done and what the process was in order to accomplish your dilation. So that shouldn't be more than 3 or 4 sentences. And finally, part number 3, you will need to do some research and find some pieces of artwork or architecture that represent various types of transformations. Choose 2 that stood out to you, discuss the types of transformations that could have been done to achieve each piece. So that one's a little bit more open-ended. Find something that kind of speaks to you. So here's some examples from each part. So I just kind of took this from Google Images. In this example here, we have our different quadrants, 1, 2, 3, and 4. And I've decided to just talk about some potential transformations that could have happened here. So to go from quadrant 1 to 2, there could have been some sort of horizontal translation to the left, maybe like, I don't know how many this ends up being, maybe about 20 units to the left, or you could have gone 20 units to the right if we're going from quadrant 2 to quadrant number 1. We could have had a reflection over a horizontal line, so we'd go from quadrant 1 to 4, or we could have had a reflection over a vertical line going from quadrant 1 until 2. Okay, so those are just some examples for you guys to use there. Example, or part number 2, excuse me. So example number 2, or an example of part 2, I went and created these colorful little blocks on some isometric grid paper. So here you'll notice that each of these side lengths of this colored cube is 2, and then I've enlarged it or dilated it by a factor of 2. So each one of these sides of the cube is now 4 units long, and I've just basically scaled everything up. I've made it look a little bit bigger. I wanted to look for or to make a shape that was a little bit different, not a cube. I'm a fan of Tetris, so I made a little T-block shape here. Just colored them different colors, and I also enlarged this by a scale factor of 2. Okay, so it's really just up to you. Do something fun with it. I was asked, do we need to color it? No, not necessarily, but if you do want to color it, it's up to you. It makes it look a little bit more fun. It makes it pop a little bit. So again, that's up to you. Don't spend too much time coloring it. I would say each one of these took me about 5 to 10 minutes each. I had to make some adjustments because I made some counting errors, and I ended up, either making it too big or too small. So make sure that you guys are adjusting what you're doing, and if you need to make any adjustments once you're all done, and talk about exactly what you had to do to each side to achieve the desired transformation. Part number 3 here. Here's an example I took. So this is a picture of the Pentagon, the headquarters of the U.S. Department of Defense. So some types of transformations that we can kind of point out here. I had some students offer some suggestions. You could have had a reflection. If this was a vertical reflection line, we could have flipped this half to this half, or this half to that half. So that's one potential. We could have had some rotation. So we could have rotated this quadrilateral over here, could have rotated over here, could have rotated over there. I had another student point out that, hey, this could have been a dilation. We could have taken this smaller pentagon on the inside. We could have enlarged it to make the larger pentagon on the outside. So lots of really cool transformations that we can potentially see in this picture. So you guys are going to choose 2 of your own and talk about some possible transformations in your own examples. So in part number 1, there's 2 different options that you can use. Of course, you can use provided graph paper that I have down here, so you can print off a couple copies of that. Or you can use something called the Pixel Art Maker, so that's located online. So if I just quickly go over and give you guys a quick demo here. So Pixel Art Maker, you just go to pixelartmaker.com, and you can make your own Cartesian grid. Oh, I want to make mine black actually, so I'm going to go ahead, color that black. Oh, let's start over. So we're going to make this black, and I'm just going to make a straight line up and down, and I'm just going to go like that. And I could come up with some sort of little itty bitty box if I'd like. So let's make a box, and we're going to color it. I don't know, let's color it. Sure, we can color it black. So we're going to color this box black. Now what would happen is I would need to color or mark each of my vertices here. So let's mark each one of these using red. So I've got one vertex that is not making it, or not marking my vertex. I'm going to actually use this tool here. I'm going to go 1, 2, 3, and 4 vertices there. Now the issue with using this is if you want to type out your vertices, you can't really do that. So just for demonstrations purposes, I know that this point here, let's call that A. We know that's going to be -1, +2. So we have -1, +2. And if we were to do a vertical or a horizontal translation, let's go 4 units to the right. So we're going to go 1, 2, 3, 4, and then 2 units up, 1, 2. We'd have our new point there, and this looks like it's going to be 3 and 1, 2, 3, 4. So we're going to have 3, 4 as our new as our transformed vertex there. We can essentially build out the rest of our box like so, and we're going to of course label each vertex appropriately. Like I said, you might want to look for some different options if you aren't a fan of doing this digitally. Now, how do you save this? Well, you just go click this little floppy disk here. Kind of aged myself. If you don't know what a floppy disk is, go Google it. You're gonna have a great time. These things held a ton of storage back in the day. So you click that, and you're gonna go ahead and drag over a section of the section of canvas that you're trying to save. I called mine example, and we can go, I called it private, or I made sure it's private. I'm gonna go save, and it just gives you a link that you can copy and paste. You can copy this onto a Word document or something, and then you can put a text box over top if that's something that you would prefer to do instead. All right. So once you go back to your project here, you've got your rubric. Make sure that you guys read through this rubric so you know exactly what I'm looking for. Again, just a quick 12-point scale for you guys to look at. And then I also provided some isometric grid paper for you guys over here. So just as a quick demo for you guys, I will just quickly draw some sort of random image or 3D object that you guys can, kind of see. It doesn't really take a long time to make your own little image. I wouldn't recommend spending more than 5 minutes thinking of the original. This isn't meant to be a project that takes you hours and hours and hours. It should be much quicker than that. So here's a quick little demonstration of how to create your own 3D object. So of course you want to make something a little bit more interesting than just a cube. So perhaps you want to do like a small little cityscape or something. So you want to change your way of thinking and understand that we're now kind of drawing everything at a slant, so we're able to see certain objects, we're able to hide certain objects. So keeping that in mind, I'm going to draw a couple of little rectangular blocks here, so it looks maybe something like this. Let's go and draw this. So I've got a little, maybe this could be a potentially little storefront, okay, otherwise known as a triangular or rectangular prism. And I'm going to go ahead and maybe put that right next to a larger building or a larger shop here. So of course I run out of room here, but if we can kind of imagine things going back a little bit more and look kind of like that. And then we can go ahead, we can make some interesting designs or whatever. You can make a little band there. I could put, a nice little portion that looks like that. That could be like a street corner or whatever. I could have maybe a little door here for people to go into. And of course, it'll be a little bit tougher. You want to make sure that all of your numbers work pretty well. So it'd be much easier for me to scale this up by a factor of 2 than by a factor of 1/2, because all of my units here, they're not all necessarily divisible by 2. So for example, this doorway, it'd be a 2 by 1. So it'd be really hard for me to figure out, or for me to, accurately portray that as having half of a unit long or half of a unit's length in its dilated form. So you could do something like that. There's lots of different ideas. Again, this took me maybe a minute to do, but you just want to play around with it, have some fun with it. Don't go too crazy, but again, push yourself a little bit, be a little bit more interesting. Don't just give me a cube. Other than that, thank you guys so much for watching. Stay tuned for the next video, and as always, keep washing your hands.